Have you ever pondered on how your pencil works? What makes it leave a mark on paper? It's something we've all taken for granted, yet it's a question that hides a fascinating story. Today we're going to unravel that mystery. Our journey takes us deep into the world of a common yet extraordinary mineral. This mineral is an everyday marvel, silently shaping our world in ways we seldom appreciate. So, what's this mysterious substance that's right under our noses, you ask? The secret lies in a mineral known as graphite. Graphite, a naturally occurring form of crystalline carbon, is a native element mineral. This intriguing substance is structurally distinct, and it's this unique configuration that gives rise to its characteristic appearance and properties. You see, graphite is composed of layers of carbon atoms arranged in a hexagonal lattice. This hexagonal array forms sheets, and it's the stacking of these sheets that manifests as the dark grey or black mineral we know as graphite. This structure is also responsible for its metallic luster, a quality that makes it easily identifiable. The formation of graphite is fascinating. It's found in both metamorphic and igneous rocks. In metamorphic rocks, graphite is produced from carbonaceous material that has been subjected to intense pressure and high temperatures deep within the Earth's crust. On the other hand, in igneous rocks, it forms when carbon compounds in the magma are reduced, leaving behind the elemental carbon in the form of graphite. Interestingly, graphite is one of the two mineral forms of carbon. The other form is something we're all familiar with, the sparkly, precious diamond. Yet despite being composed of the same element, their physical properties are worlds apart. This is due to the different ways the carbon atoms are bonded together in each mineral. Though graphite and diamond share the same parent element, their properties couldn't be more different. Graphite might look like an ordinary dull stone, but it possesses some incredible properties. First off, let's talk about graphite's atomic structure. Graphite is made up of carbon atoms aligned in a hexagonal lattice. This unique arrangement gives rise to layers of carbon atoms, which can slide over each other easily. Ever wondered why the tip of your pencil smears a grey streak across your paper? That's graphite's layered atomic structure at work. The ease with which these layers slide over each other makes graphite soft and slippery, perfect for leaving a mark on paper. Moving on to its other properties, graphite is an excellent conductor of heat and electricity. Now, you might be thinking, isn't it unusual for a non-metal to conduct electricity? Absolutely. In fact, graphite is the only non-metal that conducts electricity well. It's due to the free electrons in its atomic structure that can move around easily, carrying an electric charge. Another significant property of graphite is its high resistance to heat. It can withstand temperatures of over 3,000 degrees Celsius without melting or vaporizing. Imagine that. This heat resistance, combined with its electrical conductivity, makes graphite perfect for use in electrodes, batteries, and other applications in the electronics industry. But that's not all. Graphite is also chemically inert, meaning it doesn't react easily with other substances. This property makes it ideal for use in industries where resistance to corrosion is necessary, such as in the manufacturing of chemical containers. And let's not forget its ability to absorb fast-moving neutrons. This property is particularly useful in nuclear reactors, where graphite acts as a moderator to slow down neutrons and allow a controlled nuclear reaction to take place. In conclusion, graphite might seem ordinary at first glance, but when you delve into its properties, it is anything but. From its unique atomic structure to its excellent conductivity, resistance to heat, and the fact that it's the only non-metal that's a good conductor of electricity, graphite is a material that's full of surprises. These properties have made graphite an indispensable material in various industries. From the tip of your pencil to the battery of your electric car, graphite is everywhere. This humble mineral, often overlooked, plays a vital role in many aspects of our daily lives. Let's start with something familiar: the humble pencil. For centuries, pencils have been our go-to tool for jotting down ideas, unleashing our creativity, and recording our world. But what makes a pencil work? It's actually the graphite at its core. When you move your pencil across a piece of paper, the graphite leaves a thin layer behind, creating the lines that form your words and drawings. But graphite's use extends far beyond the realm of stationery. It's also a key component in batteries, especially those used in electric vehicles. Graphite serves as the anode in lithium-ion batteries, which are commonly used in electric cars and portable electronics. It has a unique ability to intercalate lithium ions between its layers, enabling these batteries to store and release energy efficiently. So the next time you're marveling at the speed and efficiency of an electric car, remember to give a nod to graphite for its crucial role. Now let's shift gears and talk about lubricants. Graphite may not be the first thing that comes to your mind when you think of a lubricant, but it's actually quite effective. Thanks to its layered structure, graphite can slide easily, reducing friction between moving parts. This is especially useful in high-temperature and high-pressure environments where traditional oil-based lubricants would fail. So, from heavy machinery to locks and hinges, graphite ensures things run smoothly. But wait, there's more. In the realm of steelmaking, graphite is a prized resource. It's used as a liner for ladles and crucibles, and as a component of protective coatings for steel. Its high melting point and ability to withstand extreme temperatures make it ideal for these applications. Moreover, graphite electrodes are used in electric arc furnaces, a key part of the steelmaking process, where they help to melt scrap metal. Furthermore, graphite's high thermal conductivity, combined with its strength and chemical resistance, makes it ideal for use in the manufacture of heat exchangers, fireproof materials, and even components for nuclear reactors. In the field of electronics, graphite's conductive properties are harnessed in the production of graphene, a single layer of carbon atoms arranged in a two-dimensional honeycomb lattice. This wonder material holds the promise of revolutionizing everything from solar cells to biomedical devices. The uses of graphite are as varied as they are vital. Its unique properties have cemented its place in our world, from the mundane to the cutting edge. So the next time you pick up a pencil or step into an electric car, take a moment to appreciate the graphite that makes it all possible. Indeed, it's hard to imagine a world without graphite. So, what have we learned about graphite? Firstly, we unraveled the definition of graphite. It's a naturally occurring form of crystalline carbon that's renowned for its remarkable properties. It's found in igneous and metamorphic rocks, and it's even present in meteorites that have graced our planet from the vast cosmos. We've delved into the unique properties of graphite, which make it such an intriguing substance. Its layered structure, for instance, gives it the ability to conduct electricity, a property quite rare among minerals. It's also an excellent lubricant, thanks to the weak bonds between its layers that allow them to slide over each other with ease. The strength within those layers, though, gives graphite a high degree of hardness and resistance to heat, making it a substance that is both soft and tough at the same time. Then there's its lightness and buoyancy, which are surprising given its metallic appearance and texture. It's this paradoxical combination of characteristics that make graphite a marvel of Mother Nature. Its ability to absorb fast-moving neutrons makes it indispensable in nuclear reactors, while its high thermal conductivity is ideal for heat dissipation in electronic devices. But the uses of graphite are not limited to the realms of science and technology. Its applications permeate our daily lives in ways we often take for granted. Graphite is the lead in our pencils, giving us the ability to write, draw, and express our creativity. It's in the batteries that power our handheld devices, and in the brakes that keep our vehicles safe. It's even in steel manufacturing, where it's used as a component of refractories. So the next time you find yourself sketching a doodle, jotting down notes, or simply scrolling through your phone, take a moment to appreciate the wonder that is graphite. It's not just a mineral, it's a testament to the beauty and complexity of the natural world. Next time you pick up a pencil or hop in an electric car, remember the amazing mineral that makes it all possible: graphite.